Alright guys, so this is the second video of 10-4. If you haven't watched the first video, watch that one first. Okay, we're going to do the second and the third theorem, and this shouldn't take very long at all. Okay, so the second theorem talks about inscribed right triangles. Okay, so you should know what an inscribed triangle is, or an inscribed quadrilateral. So remember, that's just when we have a triangle that all three vertices are on the circle. Okay, so ABC, triangle ABC would be considered an inscribed triangle. So it says if a right triangle, this should be a triangle, not angle, okay, is inscribed in a circle, okay, then the hypotenuse is going to be the diameter. So in other words, we have a right triangle. This would be our right angle, meaning that AC, which would be our hypotenuse, is also a diameter of the circle. Okay, now on the flip side, the other way is true as well. If one side of an inscribed triangle is a diameter, okay, so we're saying we don't know if it's a right angle, but we do know that it's inscribed in a circle, and we do know that one of the sides is a diameter. Okay, we could also use this theorem to know that yes, it is in fact a right triangle. Okay, and then this would be the hypotenuse, which means the angle opposite of the diameter would be this one right here, and it would be your 90-degree angle. Okay, so if I look at example 1 and 2, if I look at this triangle, okay, I see this right here. I see a diameter as one of the three sides of an inscribed triangle. Okay, now because it's a diameter, that means it's going to be the hypotenuse of a right triangle, meaning that this has to be a right angle. Well, if it's a right angle, it's 90 degrees, so just 2x is equal to 90. Divide both sides by 2, and I'd get x is 45. Okay, pause this, do example 2 real quick. Don't think too hard. It's not meant to be hard. Okay, and then unpause to see if you did it correct. All right, so hopefully you worked through this one on your own. Okay. Okay, so hopefully you pause this and did it on your own. Okay, same concept as the other one. Okay, we have an inscribed triangle. We know one of the sides is a diameter, meaning that it has to be a hypotenuse. And if it's a hypotenuse, that means this has to be a right angle. So the 5x is equal to 90. And if you solve for x, you get x is 18. Okay, now last one, the inscribed quadrilateral theorem. Okay, this only works for inscribed quadrilateral. So once again, inscribed quadrilateral, every point, each of the 4 points has to be on the circle. Okay, and this one's really simple. If you know it, if you don't know it, you're probably not going to get the correct answer on a test. So a quadrilateral can be inscribed in a circle if and only if, so this goes both ways, its opposite angles are supplementary. Okay, now hopefully you haven't remembered everything you learned from first semester, but supplementary means they add to 180 degrees. Okay, so in other words, we have a inscribed quadrilateral here. Okay, so opposite angles, E and G would be opposite of each other, and then F and D would be opposite of each other. So essentially, because of this theorem, angle F plus angle D is 180, and likewise angle E plus angle G is equal to 180. Okay, so if I look at example 1, okay, angle D and angle F would be opposite, angle E and angle G would be opposite. Okay, so opposite angles are supplementary, meaning that z plus 80 has to equal 180. So minus 80. Z then has to be 100. Okay, and then same is true for y and 120. Subtract 120 from both sides. I get y is 60. Okay. All right, now it's not always that easy. Sometimes we have to use stuff we've learned previously. So let's look at this. Okay, we have an inscribed quadrilateral. Okay, we know this arc is 54, this arc is 130, this arc is 180. Okay. And I know that opposite angles have to be supplementary because it is an inscribed quadrilateral, meaning that this angle and this angle would be supplementary. And then this one and this one would also be supplementary. Okay, but the problem with this is that we don't have any angle measures, okay? But we can find angle J because if we look at this, okay, we can use a previous theorem. Okay, we know the intercepted arc is right here in blue. Okay, well, all the way around, 130 plus 110 would be what? 240 degrees? Okay, and remember our first theorem of this section is that the inscribed angle is half of that, meaning that this has to be 120 degrees. Okay, now that I know this is 120, remember the yellow ones, J and L, are supplementary, so 120 plus 3A is equal to 180, and then it's just simple algebra, so subtract 120 from both sides. 3A is 60. Divide by 3, you get A then has to be 20 degrees. Okay, now I'm going to do the same thing for angle K. I'm going to find the measure of angle K. So if I draw angle K, it's here and here. Okay, meaning that its intercepted arc is from J to L right here. So that would be 54 plus 30, which would be what? 54 plus 130, that's 184. 184. Okay, and then angle K is inscribed, that's the intercepted arc, so it has to be half that. Okay, so 184 divided by 2 gives you 92 degrees. Okay, well then angle K and angle M are opposite angles, so I know that 92 plus 4B are supplementary, so they'd have to add to 180. So minus 92 from both sides. You get 4B is equal to 88. Divide by 4, you'd get B is 30. All right, so after you're done taking these notes, there is a big ideas math homework assignment. Make sure you get on that.